All right, this is going to be one of the most challenging things that you'll do all year because we have all these things put together. The idea is you make it make sense. We're correcting wrong chemical equations. So, each chemical equation will contain errors in this section. Carefully examine each and correct the error, then explain why each error was wrong. So this is not only doing the skill, but explaining why that was wrong in the first place. So there's a few things that can be wrong. It's the wrong pattern, such as they did a double displacement when it should have been a combustion. This would also cause wrong chemical formulas. So some correct examples: NaCl, H2O, CO2. Incorrect, where they maybe put the nonmetal first. Or they have two nonmetals put together and they like crisscross some weird stuff. Or something like strontium nitrate, which should have two nitrates, not just one. Or could be having some elements that are diatomic when they shouldn't be, or things that they put as one atomed when they should be diatomic. The last part that can be wrong is it's unbalanced or incorrectly balanced chemical equations using the wrong coefficients. Those are the numbers that go in front of the chemical formulas. Now, the wrong pattern used will get you the wrong result. So you need to know and remember and be able to apply these different ones. We're not doing decomposition, because that's too complicated when you have some examples that are a little bit more complex. Replacements happen to like items. So when you have single or double replacement, the positive ion will replace the positive ion, or the negative ion will replace the negative ion. Keep that in mind. When it comes to the correct chemical formulas, this is super important, because if you have these being wrong, your balancing is going to be wrong as well. So remember, when you have ionic compounds, those are things that are metals and nonmetals bonded together. They use polyatomic ions, which you find on the back of your reference sheet. The positive ion goes first, then the negative ion, cross the charges, and then make sure they're the lowest ratio, meaning that they can't be reduced anything further. Combustion always gets CO2 and H2O as products. I find this one the simplest because of the fact that, well, there's only one option. Most elements are monatomic, meaning one atom. All of your metals and stuff are going to have one. Then there's these 7 diatomic elements that you need to be aware of and be able to apply to any of these situations. Now, steps to correcting these chemical equations. You first need to determine what type of reaction is taking place. That will be the basis of how you know what products should be formed. For number 2, make sure that you have the correct chemical formulas based upon the rules for making chemical formulas and types of chemical reactions. Crisscross if it's an ionic compound, which most of these will be. Make sure you have the correct coefficients once you have those correct chemical formulas, because it needs to be balanced. The last part is kind of backtracking, looking at what you corrected to explain in your own words what was wrong with the reaction and correcting the issues. I think a good tip is to go step by step through this thought process. All right, so let's take a look at some examples. I know that's what you might be thinking, but they're not that bad. So let's take a look. So we have metal and a nonmetal, that's a compound. Metal and a nonmetal, that's a compound, making 2 other compounds. So 2 compounds making 2 compounds, that's a double replacement reaction. Now we need to evaluate what are the correct chemical formulas. So we need to look at the charges for each of these. So I'll go through and I would just label what each of these charges are for these types of ions. These would be found on the back of your periodic table if they're polyatomics, or following the patterns we've gone through numerous times in order to get there. 3 minus. Okay, so we need to see, did they do this correctly? Well, 1 sodium and 2 chlorine, because these have the same number but are opposite charge, this one is not the correct chemical formula. Here we have 2 phosphates, 3 calcium. No, it looks like they only put 1 phosphate, so this is not correct either. 2 down here, 1 down here. Yeah, that's all right. 1 of the phosphates and 3 of the sodiums. Yep, That one's okay too. So we need to go back and make this a correct chemical formula. Now we have one of each, one Na and one Cl, because these have equal and opposite charge. Plus, we should have the 3 calcium, because of the 3 minus charge being crossed down, but I need 2 phosphates. So PO4, 2 minus, or 2 I should say. And then these were correct, right? CaCl2 and the Na3PO4. So now I have the chemical formulas. Now I need to balance it. So I'll start off. I've got 1 sodium, and I have 3 sodiums. So I need to put a 3 here in order to balance that out to be the 3 sodiums. The previous ones, you can go ahead and just ignore those. Don't think that they're going to be right for any reason. So we've got 3 sodium, 3 sodium, 3 chlorine, and I see I only have 2 chlorine here, so that kind of creates a conundrum. We need to have equal and opposite. So the lowest multiple for this would be 6 for 3 and 2. So that's going to make me put a 3 here, so I get 6 here. I'll come back and change that in a little bit. Here I've got 3 calcium, and because I have 3 times the 1, that would be 3 calcium. 2 phosphates, because I have those in parentheses, and I see I've only got 1 here so far. So I'll need to put a 2 in front to give myself 2 phosphates. That's going to change my sodiums to 6. That means I need to go back here, cross that out, give me 6. So now I have 6 sodium and 6 chlorine. And that's why I'm going to come where I'm at where's my sodium? 6 sodium. So now it's all balanced with the correct chemical formulas. Now, what was wrong with this? Well, the coefficients were wrong since chemical formulas were wrong. Next, NaCl2 and Ca3PO4 did not cross their charges correctly. That's why the chemical formulas were incorrect. You see, you identify the wrong things, and of course we fixed what is right. We're going to come back and do the last 2, and let's see how we can do with those. See you soon.